Good day everyone, welcome, and today we'll be discussing geometric progression. Geometric progression (GP). Now a geometric progression is a list or sequence of number where each term is obtained by multiplying the previous term by the same number, either multiplying or dividing as the case may be. This fixed number is called the common ratio, and to get the common ratio is gotten by the second term divided by the first term, or the third term divided by the second term, and so on and so forth, the fourth term divided by the third term. That's how we get our common ratio. Now we have an example: 1, 2, 4, 8. Now as you can see, we observe that the common ratio in this case is 2, because 2 times 2 is 4, 4 times 2 is 8. Now the very first term we'll be discussing is the nth term of a GP. Conventionally, when we work with GP, we denote the first term by the symbol A and the common ratio by the symbol arrow. And in general, for any GP, the terms are: our first term is A, and we know that we are multiplying it by our common ratio, so our second term will be A arrow, our third term will be A arrow times arrow, which should be A arrow square, our fourth term will be A arrow square times arrow, which should be A arrow cube, so on and so forth till we get to A arrow raised to the power of n. So by observation, you will find that the nth term Tn will be equals to A arrow raised to the power of n minus 1. We are looking for our fourth term, we are using arrow raised to the power of 3, so it's n minus 1. Now we have an example that states that determine the third term of a geometric progression whose first and fourth term are 4 and 108 respectively. So we are given the first and the fourth term of the GP, and we are asked to look for the third term. Now recall our nth term of a GP. Tn is equal to A arrow to the power of n minus 1. Now to determine the third term, we need to know arrow apart from the given A, which is our first term. So the only way to get third term, we need arrow, because t will be A arrow to the power of n minus 1, and we currently don't know arrow. Now the way to go around this, we're going to be using what we are given, and first of all looking for arrow. So we know we are given the fourth term, so our T4 will be equals to 108, which is given, which will be equals to 4 times arrow to the power of 4 minus 1 using our formula. So 108 will be equals to 4 arrow to the power of 3, and dividing both sides by 4, it becomes 108 divided by 4 is equals to arrow to the power of 3. So it becomes 1 divided by 4 is 27, so 27 will be equals to arrow to the power of 3, and find the cube root of both parts, arrow will be equals to 3. Now to get our third term, T3 will now be equals to A arrow raised to the power of 2, because 3 minus 1 gives us 2. So T3 will be equals to 4 in bracket 3 raised to the power of 2, which will now be equals to 36. We have another example that states that the third term of a geometric progression GP is 360 and the system is 1215. Find the first term, and this example is from WAEC. We're given the option, so applying the general formula for n term, we know that Tn is equal to A arrow raised to the power of n minus 1. So for our third term, this becomes T3 will be equals to 360, because we are given a value which will be equals to A arrow raised to the power of 3 minus 1. So simplifying that, it becomes 360 is equals to A arrow to the power of 2. This will be our equation 1. Also for our system, T6 will be equals to 1215, which is equals to A arrow to the power of 6 minus 1. Simplifying, it becomes 1215 is equals to A arrow raised to the power of 5. This is going to be our equation 2. Now solving both equations simultaneously, we are going to be dividing equation 2 by equation 1. Doing so, it becomes A arrow raised to the power of 5 divided by A arrow raised to the power of 2 be equals to 1215 divided by 360. So dividing becomes arrow cube will be equals to 27 over 8, which is also equals to 3 cube divided by 2 cube, which can now write in the form 3 over 2 in bracket is the power of 3. As you can see, we can find the cube root of both sides, and arrow will be equals to 3 over 2 by 3, or you can easily just equate arrow to be equals to 3 over 2 by comparison. Now substitute arrow equals 3 over 2 by 1. It becomes 360 is equals to A in bracket 3 divided by 2 to the power of 2. which multiplying it becomes 360 is equals to 9a divided by 4, and cross multiplying 360 times 4 will be equals to 9a, which makes 1440 is equals to 9a. Dividing both sides by 9, a will be equals to 1440 divided by 9, and a will be equals to 160. Sum of n terms of a GP. Now the sum of n terms of a geometric progression GP is Sn, or is represented by Sn, is equals to a in bracket 1 minus r raised to the power of n divided by 1 minus r. Now this formula holds only when r is lesser than 1. So when r is lesser than 1, we use this formula, but for when r is greater than 1, we use the formula Sn equals to a in bracket r raised to the power of n minus 1 divided by r minus 1. This formula holds only when r is greater than 1. So depending on the value of your r, you choose the appropriate formula. Now we have an example. It's from PCE 1999. It states that find the sum of the first 5 terms of a geometric progression whose first term is 3 and its common ratio is 1/4 to 4 significant figures. Now for our solution, since common ratio is 1/4 and it's lesser than 1, we use the formula Sn is equals to a in bracket 1 minus r raised to the power of n divided by 1 minus r. Substituting for a and r in our formula, S5, that is the sum of our first 5 terms, will be equals to 3 in bracket 1 minus 1/4 in bracket is the power of 5 divided by 1 minus 1/4, which should break down to Sn is S5 rather is equals to 3 in bracket 1 minus 1 divided by 4 is the power of 5 divided by 1 minus 1/4. Simplifying our bracket and our denominator, S5 will be equals to 3 in bracket 0.9990, that's 1 minus 1 divided by 4 is the power of 5 is 0.990 approximately, divided by 0.75 our denominator. And when we divide this, S5, or the sum of the first 5 terms, will be equals to 3.996 to 4 significant figure. Our final question states that how many terms of the series 3 minus 6 plus 15 and minus 24 are needed to make a total of 1 minus 2 raised to the power of 8. Now the series is a GP with arrow which is equals to minus 2, because minus 6 divided by 3 is minus 2 and plus 2 divided by minus 6 is also minus 2. So our common ratio is obviously minus 2. Now since our arrow is lesser than 1, the formula we are going to be using is Sn is equals to a in bracket 1 minus r raised to the power of n divided by 1 minus r. Now substituting a and r in our equation, 1 minus 2 to the power of 8 will be equals to 3 in bracket 1 minus in bracket minus 2 raised to the power of n divided by 1 minus in bracket minus 2. This is simplified to 1 minus 2 to the power of 8 will be equals to 3 in bracket 1 minus minus 2 in bracket to the power of n divided by 3. The 3 in our numerator and our denominator is going to cancel out, so we'll be left with 1 minus 2 to the power of 8 is equals to 1 minus in bracket minus 2 raised to the power of n. Now it would have been easier to compare, but as you can see, we have minus 2 in bracket on the right hand side and 2 on the left hand side, but we are going to be making a very crucial assumption. Since we know that n is even, that is n is equals to 8, so therefore minus 2 to the power of n will also be equal to 2 raised to the power of n. So we know that minus 2 to the power of n will also be 2 to the power of n. So we know that our bracket can also be 2, like it is equivalent. So therefore we cannot compare, noting these assumptions. So minus 2 will be equals to 2 in a manner of speaking, and n will now be equals to it. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Fact Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in a soft copy, you can get it at the website on the bottom of the screen. Thank you.